2, 1, start. Alright, let's try this again. I've recorded this like so many times. So, final project presentation from Juan Marcos and Sina. This is going to be our calculator project. So, I think a good place to start is by actually running the program and showing you what it does, and then we can move on to the code and how it works. So let's run it quick. So here we have our calculator program. The division, addition, multiplication, and subtraction work exactly as one would expect them to. So we can multiply stuff together. We can add stuff together. We can divide stuff together, and subtract stuff. It gives, right? Let's say we're inputting a number and we decide that we actually messed up, and instead of 856 we meant to put 853. And click on the backspace or delete button and then click on the right button. So we have a delete function. We also have a decimal point right here. So let's say we want to do 36.3, so 36.3. Or let's say we want to do 3.333333 times 3. Right. So we have, what else do we have here? We can talk about, we have the matrix function. So that is this comma and this M for matrix. And this is a really interesting one. So the idea here for this matrix function is to compute the eigenvalues of a 3x3 matrix. But inputting a 3x3 matrix in this rectangle up here, this text field that is only one, you can't put two-dimensional arrays in here without them looking funky. So the way we do that, the way we input a 3x3 matrix is by doing the following. Let's do 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma, oh, missed the 5, 6, comma 7, comma 8, comma 9. So what that's doing, so if you look here at the notes here at the very beginning, when you input when you input a string of numbers separated by commas, the program will interpret that as a 3x3 matrix. So here we go. What this string of numbers actually represents is the following matrix. So it's just gonna go down here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this 3x3 matrix here is represented by this string of numbers over here. So when we click enter, that the result should be the eigenvalues of this 3x3 matrix over here. So let's click enter real quick. Oh, here we go. And here we get these values over here. We can always check this to see how correct it is. So let's do this real quick. So the matrix we're working with, so we're going to do eigenvalues. We have 1, 2, 3, 4, 5, 6. 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. If we look at our input matrix right here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the correct matrix. Now, according to Wolfram Alpha, the eigenvalues of this matrix are, here we see, oh, no, I don't want to go pro. That the first eigenvalue is 16.1168. The second eigenvalue is negative 1.11684, and the third eigenvalue is 0. We compare that. Let's compare that to our calculator over here. Let's open this up again. And we see 16.12, 16.1168, negative 1.12, negative 1.12, and 0, 0. So we do indeed have the three eigenvalues of the matrix that we have. I might need that later. Of the matrix that we have inputted. So this is how the calculator works. Let's look at the code behind it real quick. So this is where the meat and bones of the code start. So this here is where we're setting our frame, our window that we're going to be working with. This real quick. This is where we're setting up the text box, where everything is being inputted and outputted to. And here is where the main bulk of the code is going to lie. Here we're initializing each button we're going to use. So here we're initializing the clear button, the comma, the 9, the 2, the decimal point, and so on and so on. Once all the buttons are initialized, we're going to have to describe what each button is doing. So there's two types of buttons. There's buttons like 6 or 9 or 7 here, and these buttons, what they're going to be doing, let's click on this real quick. Alright, so when you click on a 6 or a 7 or a 9 or even a decimal point, all that's happening is that a number is being put on the screen. There is no calculation being done yet. The second type of button is the function button. So that would be buttons like the multiply button, and then you have to put a new button number, or the equal button, or the delete button. So those are the two types of buttons. There's the buttons that display things and buttons that perform functions. So let's look at the display buttons first. So we'll look at button 7 over here, but all the numbers and the decimal point and the comma will be the same, so that way you don't have to look through every single button. So let's look at button 7 over here, and here we go, button 7. So the first couple lines of code tells us how the button is going to look. We know that it has a black foreground but a gray background. Here we have the font, here we have the position and size of the box, and here is the event that happens when you click the button. So all that's going on for this button is that we're declaring a string variable called enter number, and that string is going to be equal to the text that is already on the text field plus the text from the button. So in the case of our let's run this real quick. Let's say that 56 is already on the text field right here. If we click 7, then the enter number variable is going to be equal to 56 plus the 7. Then we're going to use the set text method for the text field to put that new number, 56 plus 7, into the text field. So 56 plus 7, when there's strings, is 567. And you can see, open this up, here it is, 567. So the same thing happens for the period, and the same thing happens for the comma and the 0. So it's pretty straightforward. The next thing to look at, let's look at the delete function. It's all the way at the bottom over here. So again, the first 4 lines of code talk about how it looks. Here we have its location and size. Here we have its colors, its fonts, whatever. So what we're doing here for the action of pressing delete is that we're declaring a string backspace, and then we're going to get the text that is already on the text field over here. If there is no text on the text field, then this if program is not gonna run. But if the text field is empty, or if the length of the text field is 0, then if doesn't run. But if we do have something in the text field, so if we have a calculator and it's already empty, then this doesn't do anything. But if we have a 3, 2, 1, then delete does work. And that's because we're going to use string builder to subtract one character, delete the character at the very end of the string that is in the text field, and save that to backspace, and then just set the text equal to that new string that is equal to the same string without the last character. I hope that makes some sense. It's I've been recording this like 20 times, and it's getting harder to talk about this. But anyway, so yeah, so you delete and you can put a new number instead. The other functions we want to look at, we'll look at equals at the very end. That's the most important one. But let's look at any other function. So if we look at our calculator, we talked about delete. We talked about the numbers. Let's talk about clear. Clear is pretty simple too. So we're going to go clear at the very top, actually. Here we go. And what you'll notice is that for the functions, the first thing we're doing is we're setting the color to black for all the buttons. The reason why we're doing that is because when you look at the calculator, you'll see that we'll put in a number, and let's say we want to add. When I click the add button over here, it's going to turn the button green, and that's going to tell the user that the add function is currently on. And so now that the add function is on, we can add a new number, and then when we click eClose, it cancels that. And so that's how we're able to tell if we have a function running in the background or if we need to click add. So the reason why we're turning everything black here when we press clear is because we want to clear the function as well, and this will tell the user that the function has been cleared. But the main thing that's happening when you press clear is this single line of code here. You're using set text method to put the text field to null so that nothing shows up. That's a pretty easy way to clear the screen. The other functions we can look at, let's look at some of the more basic ones. Let's look at addition, for example. So right here, and I spelled it wrong. That's embarrassing. Okay. So again, the first 4 lines of code describe how the button looks, and then the first line of the event is turning everything black. But then here we have the actual function. So when you press the addition button, the first thing we're going to do is that we're going to save the current text on the text field into a variable called number1, or right here. Then the next thing we're going to do is that we're going to clear the screen again, text field, and then we're going to set a variable called function equal to this string over here. And each function has a specific string that it's equal to. And this function will be called later in the eClose button. So if we go here, we have a number 152 in the text field. When we click plus, it's going to save this number into the variable number1. So we're going to click plus, and now 152 is saved into number1, and the screen has been cleared for you to be able to put your next number. So the next number will be 125. So then when you click eClose, let's look at the eClose sign now. And it's towards the bottom as well. Here we go. Again, as per usual, turn everything back to black. But here we have a switch function. We have a switch loop, not a loop. We have a switch situation going on here, where we're switching the function. And so we click plus, so our function is this one right here, where we said earlier that when you click plus, you set function equal to this string. Well, the program's gonna run through these cases until it finds the case of the function that you clicked. So for plus, now we're going to also save the current number on the screen. So this is a new number. Remember, number1 has been saved already. So num2 this number here will be saved as num2 when you click eClose. So, and we're doing that using getting the text from the field and turning it into a double using the parse double method. So you click eClose, and number2 has been saved. Then, under the variable result, you're going to get the outcome of the variable number1 and number2 added together, and then you're going to turn that double result into a string using the string format, and you're going to keep it to 2 decimal places so that it's readable. And then you're finally going to use the set text method to set the text equal to what the answer was. So in this case, it was 277. For different functions, they're all pretty straightforward. For minus, instead of addition over here, you're going to be subtracting, but the rest is exactly the same. For multiplication, there's that, and then for division, we have this here. Where it gets really interesting, and where a lot of the work came in from, was from the eigenvalue calculation. So let me demonstrate that real quick. Actually, I think I already did. Yeah, I think I already did. I I don't actually remember if I demonstrated the matrix. Well, I might do it again later, but I'll assume we did. The way this works is the first thing we're doing is that we're going to get the text that's on the field. So let's open this up here real quick and clear it. So let's say that this is what the user has inputted. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So the first thing we're going to be doing is in the string variable called matrix input right here, we're going to use the get text method to get the text from the field and set that equal to matrix input. Then what we're going to do is that we're going to tokenize that input using the comma as a delimiter. So if you look at this string over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, the next thing we're going to be doing is since we're using a comma as a delimiter, we're going to be creating an array of 9 strings, where the first string is a 1, second string is 2, 3, 4, 5, 6, 7, 8, 9. Anywhere there's a comma, we're splitting it up. Then what we're going to do, using this for loop over here, we're going to turn each token that came from the splitting over here, and we're going to turn that into a double. So right here, actually I think I have it up here. And we called the double tokenized, for lack of a better name. And I'm being generic here, but assume A is a double and B is a double, C is a double, because I'm trying to be generic with this explanation. So yeah, so the 0th element in the array becomes a double using the parse double method. Then the first element, then the second element, and so on and so on and so on, until you have an array of 9 elements. And then what we're going to do is that we're going to use, we're going to create here a 2-dimensional array of doubles that has a size of 3 by 3. And we're going to call it vals, that stands for values. And then we're going to initialize just what's the word? Just a variable to help increase our counter for our nested for loop over here, where we're going to be turning our array of doubles into a 3 by 3 matrix. The way we're going to do that with this for loop is that if you look at here we go. If you look at how this loop is going to play out, first j is going to be 0, then you're going to move on to the bottom loop where I is 0, and then the value vals 0, 0 will be equal to tokenized 0. So here we have this over here, and tokenized 0 ends up being A in this generic example. Then I is going to increase by 1, and so is k. So then vals 0, 1 will be equal to tokenize 1. And tokenize 1 in this example will be B. Then it's going to jump up in I value to 2. And val 02 will be equal to tokenize 2. That's equal to C. And then, because I has to be less than 3, the for loop is going to end. This for loop is going to end here. And so we're going to jump back to the second iteration of this for loop up here. And so j is going to increase by 1, and when j increases by 1, this for loop here is going to repeat 3 times as well. And it's going to result in vals 1, 0, vals 1, 1, and vals 1, 2 equaling to j, 3, 4, and 5, because the k is just going to keep increasing by itself. And so that's going to, one by one, replace every element here with its appropriate value until you have the whole array figured out. And then using the JAMA library, the JAMA matrix library package, we're able to initialize a matrix variable, which you would not be able to do otherwise. And we're going to call this matrix variable input. And we're going to set it equal to the 2D array that we've solved for earlier. And so here we have our matrix input that has been derived from the string of text that the user inputted in the calculator. So this string of text is going to become a 3x3 matrix in this method. Then we're going to click equals and we're going to compute the eigenvalues. Oh, hold on, I didn't click on the M. Sorry, M. 1, 2, 3, 4, 5. Oh, missed one. Geez. 4, 5, 6, 8, 9. There it is. All right, and here we're going to compute for the eigenvalues. The way we're doing that is we're going to be using the eigenvalue decomposition library. And so we're going to set lambda equal to the eigenvalues of our input matrix here. So input.eig will compute the eigenvalues of this matrix input, and we're going to set those equal to lambda. And now, now that we have the eigenvalues computed, we want to have access to them. I'm going to close this real quick. Maybe not. I'm not going to. Oh, there we go. Now that we have the eigenvalues computed, we want to have access to them. So we're going to use the get real eigenvalues method to store those eigenvalues into a variable called eigenvalues. Eigenvalues is going to be an array of size 3, and this is because for a 3x3 matrix, you're going to have 3 eigenvalues at all times. And so now that we have our eigenvalues stored in a place that we can access them, we can turn them into strings with 2 decimal places using the string format, and we can concatenate all 3 eigenvalues into a single string here, and we're going to call it eigans, which stands for eigenvalue answers. And then we're finally going to use setText to set eigans to set the text of the calculator text field to our eigenvalues. And that's how we are able to solve for our eigenvalues. The last thing I think is worth noting is that when you run this program, there's a little note over here, but you have to make sure that the JAMA packages is installed. So let's go to the JAMA website real quick. So copy, and here we go. This is the package that was used to calculate all the matrix stuff. So JAMA is a basic linear algebra package for Java. It provides user-level classes for constructing and manipulating real dense matrices. So this is how you can work with matrices with relative ease, because it turns out for a general 3x3 matrix, I'll show you this real quick. I think it's kind of fun. Computing a 3x3 matrix is not really that complicated, besides some simple algebra. But if you want to do it generically, C, D, E, it turns out, H, I, J. I missed the letter. That's fine. If you want to compute a 3 by 3 matrix generically, it turns out that it gets really ugly really fast, and Wolfram Alpha will show us here exactly how ugly it's going to get. So this is the generic value for the first eigenvalue of a 3 by 3 matrix. This is the second value of the eigenvalue for the 3 by 3 matrix, and this is the third. And so if you want to keep things generic for the sake of code, it gets really messy really fast. And so it did really help to have a package you can install. So you can come down here and you can download the jar file. JAMA 1.0.3 is the package that was installed for this calculator project, though I suspect that an earlier version might be just as well, just as useful. And the final thing is that we were able to do a lot of this graphical interface, graphical programming really simply because we had, so we got over here, go to Eclipse Marketplace. We had a plugin called Window Builder. So let's look at Window Builder real quick. Here we go. It's composed of Designer and Swing Designer, and makes it very easy to create Java GUI applications without spending a lot of time writing code. We have it already installed, and once you install it, as the description says, it makes GUI graphical stuff really easy to program, because you click on this design little window down here, and here you have the calculator you're working with. And it's really easy to change the sizes. We can make this bigger, we can make it smaller, we can change the font here. Instead of Copper Gothic, we can do something dumb like Chiller. And it's hard to tell because it's a pretty oh geez, let's go back. The whole point is to, here we go, Chiller Century. Oh geez, I kinda, wait, Copper Gothic, that's what it was. Yep, alright. Yeah, and so you can add a button pretty easily. Just click on J button, put it in here. You can change the size. It makes programming the graphical interface incredibly simple and easy, and the only thing you have to really think about is right here in the actions, and making sure that when you click on the correct action happens. But besides that, the graphical portion, choosing the right colors and the right sizes, being able to design it with this interface does make life a lot simpler. But that is the program. This is the calculator app. By far the most fun part was definitely figuring out the eigenvalue calculation, and had we more time, we would love to add more linear algebra applications, because there's something about 2D arrays that is just a ton of fun, in my opinion. But yeah, okay. Hopefully this was a good recording and not as bad as the last one. Alright, have a good future. Bye.